Hello and welcome back. Let's continue to solve this question, which is finding the area and perimeter of the shaded region. So to find the area, what we've done is we've sort of divided the area into two pieces. We've got this piece on the right hand side, which looks like a half a circle. We have this piece over here, which is a rectangle with a little square cut out of it. So we found the area of half of the circle, which is so the area of a whole circle is pi r squared, and if we only want half of it, we divide it by 2. So the area of half the circle is going to be pi times 5 squared over 2. This is the area of half the circle. Now I need to find the area of this rectangle, but the area of the rectangle has a little chunk cut out of it. So what I'm going to do is I'm going to find the area of the big rectangle, and I'm going to subtract the area of the smaller rectangle inside. So the area of the big rectangle is just going to be the length times the height. So it's just going to be 10 times 15, which is 150. Now I need to take the area of the small rectangle, and in fact that's actually a square, and I'm just going to take 5 times 5. So to find the total area, I'm going to take the area of the half circle on the right hand side, which was pi times 5 squared over 2. I'm going to add the area of what's over here, the big rectangle, and I'm going to take away the little piece that we've cut out. And this will give us our answer. So I can come over to my calculator, and I can take pi times 5 squared, and I can take that and I can divide it by 2. I can add 150, and I can subtract 25. And my answer will be 164.2699. Let's just round this to the nearest hundredth. So it'll only be 2 places. I look one past and I see that it's a 9, so I'm going to round up. So 164.27. And again, I have to be careful here. I haven't given myself any units for this. So if these were all meters, if all these distances were meters, then this area here is going to be measured in meters squared, because this is going to be area, and area will be in units squared. So this is how I would find the area of this shape. Now the perimeter, I'm going to have to start over. So I'm going to erase most of this, and we will start over from scratch. But I'll leave this area calculation down here. So to find the perimeter, I'm just going to need to find the lengths of all of this outside. Well, some of these are pretty simple. Since this is a rectangle, the top and the bottom will have the same length. So the top is going to have 15 meters from there to there. We're going to have 15 meters from there to there. And we'll also have 15 meters, we'll also have 10 meters to get from the bottom to the top over there. So I've done all 3 of those sides, but I also need to do this side right here. So plus, and then we don't know quite exactly what this is. However, we know that this is a half a circle. So all I need to do is find the perimeter for a whole circle and chop it in half. So again, the perimeter for a circle is called the circumference. And the circumference of a whole circle is going to be 2 pi r, but I only want half of that. So I'm going to end up dividing by 2. Well, the 2's cancel, so the circumference of half a circle is only going to be pi times r. So this question mark will then become pi times the radius here. And again, the radius is going to be the distance from the center of the circle to the outside, which I can go from the center of the circle to the outside being the top. It's going to be half of 10, which is 5. So there it is. And then I can do the same thing I did before. I can come to my calculator. I can go 15 plus 15 plus 10 plus pi times 5. That will equal 57.7 if I round it to the nearest hundredth. I see in the third decimal place is 7, so I round the second decimal place up. So this is going to be 55.71 meters. Again, meters because this is a length. It is the length of the outside. So we've seen a few examples dealing with area, and it's just more or less finding the correct formula and plugging that in. We can also look at volume. So there are a few different shapes to be aware of when we're looking at volume. So again, volume, we have a three-dimensional shape. It's going to take up some space, and the volume is going to be how much space it takes up. How much stuff could we fit inside? So a rectangular prism, a prism is basically going to be, we have some shape and we'll extend it through space. So here we have essentially a rectangle and we've extended it backwards. So now it has depth to it. The volume, what dimensions do we need? Well, we're going to have a height, a width, and a depth. So the volume is just going to be, it will be equal to the height times the width times the depth. We just have those three dimensions. The height, again, how tall it is, the width, how wide it is, depth, how deep, how far back this goes. The surface area, if we look closely, we can see that, oh, this side is just going to be a rectangle. So the area on that side is just going to be a rectangle. We know that that side is going to be the height, which is this length here, times the depth. That's the area of that side. But there's also one on the back. So this guy right over there. And those are also going to, that one is also going to have length D and height H. So there's two of those sides. We also have the front up here, and that's going to be H times W. But we also have the one in the back, and that's, again, the height is H and the width is W. So we'll have two of those. Plus, well, now we've got the top and the bottom. And these are, again, just rectangles. So we're going to have a width W and a depth D. So it's just W times D. And again, there's two of them that look exactly the same. So the surface area is just 6 rectangles. The front, the back, the two sides, and the top and bottom. So rectangular prisms are quite nice. It's just a few rectangles glued together. A sphere, again with a sphere, the only measurement that we'll need for a sphere is going to be the radius. So again, it's just going to be the distance from the center to the outside, just like a circle. And in fact, if you were to chop a sphere exactly in half and you were to hold it up, it would look like a sphere. Spheres could be balls, could be say like oranges. The Earth is very close to being a sphere, although it's slightly squished because it's spinning so fast. The volume of a sphere is given by 4/3 times pi times r cubed. This is just a formula. There is an explanation why this works, but I'm not going to get into that. And the surface area would be if you were to take the sphere and sort of unwrap it. So for instance, if you were to peel an orange, and you go, well, how much area does the orange peel take up? That is given by 4 pi r squared. And again, this is just a formula. It comes up. One thing that you'll notice is that I have an area, and you'll notice that we have squares. Likewise, with the volume, we have cubed. If you remember from the last video, we will measure area in things like feet squared, meters squared, inches squared. With volume, we'll be measuring these in inches cubed, feet cubed, meters cubed. So it's easy to remember which one goes with which, because the area is in square feet, whereas volume should be in cubic feet. And then the last one that I want to do is a cylinder. And a cylinder looks a lot like a rectangular prism, but instead of having a square that we've elongated, we now have a circle that we've sort of stretched out. So this will kind of look like a toilet paper roll, like the tube in the middle. A cylinder could also be like a tree trunk or a pole, be a really skinny cylinder. So the volume, what we'll need is going to be the radius of this circle on the outside and how tall it is. So let's call that L. So the volume is going to be the area of the circle, which is pi r squared, times the length. And that's how we find the area of a cylinder, the volume of a cylinder. The surface area of the cylinder, there's going to be sort of three sides to this: the part that wraps around the middle and both ends. Well, the area of the end, well, this is just a circle, so the area of a circle is going to be pi r squared, and in fact we have two ends. One on both. So we're going to have two of those. And now we need how much surface area the center of the cylinder will have. And again, if you were to take a cylinder, say some wrapping paper wrapped around a tube, and you were to roll it out, you get a rectangle. So all we need to do is know the length and the height of of the inside rectangle, and we have that. Well, we have the length of the rectangle, L, and then how long is it? Well, we need the distance around the circle. So the distance around a circle is the perimeter, and that's going to be 2 pi r. This is the area of both of the circles on the ends, and this is going to be the area of the unrolled rectangle in the middle. You may see this surface area given in a slightly different formula as well. Both of these are exactly the same. It's just written in a slightly different way. It's 2 pi r times r plus L. Both of these mean the same thing. You can just use whichever one makes sense to you or whichever one is easier for you. Let's look at a couple of examples. So here, let's find the volume of a pool. And a pool, in this case, we're going to think of it as a rectangular prism that is 10 feet deep, 20 feet wide, and 30 feet long. Well, again, a rectangular prism, these are pretty easy to find the volume of. This is going to be 10 feet deep, 20 feet wide, and 30 feet long. And the formula for the volume is going to be the height times the width times the depth. And if we take 10 times 20 times 30, we will get 6,000 feet cubed. So this is the volume. So for instance, the pool, this would be how much water we could fit inside the pool. It would be 6,000 cubic feet of water could fit in the pool. And I'll do another example and finish up in the next video.